All right, good morning, guys. We're going to go ahead and get started on 1.5, numbers and types of solutions of linear equations. So we can see here up here at the top we have quite a lot of the definitions, but what I'd like to do is actually jump around a little bit and let's start with an equation. Let's look at problem number 1. So if you remember when we did these before, we see that there are variables on both sides. So this is where we're going to take our highlighter. As soon as I locate one. Okay, and we're going to draw our highlighter or our line down the middle to separate our equation into two. And then we're going to use our Post-it note to cover up the right side. So when I go ahead and look at my left side, I have to ask myself, does this side have any distributive property? It does not. Does it have any combining of like terms? And it does not. So now I know that the left side has been simplified. So I move my Post-it note over to the left, and I'm going to look on the right side. So again, I ask myself do I have any distributive property? And I see that I do. So I'm going to multiply 2 times x, which gets me 2x, and 2 times a positive 1, which gets me 2. So because I simplified my right side, I have to just bring down my left. So then I go and I ask myself, do I have variables on both sides? I see that I do, so I need to make sure that I get my variables to one side and my constants to the other. So first I start with my variables. So I want to figure out how I'm going to get this 2x over to the other side. So I see that it's positive, so I subtract 2x, subtract 2x. My 2x's cancel out, and then I notice, wait a second, my 2x's cancel out right there. So I bring down my -4 equals to 2. So does -4 equal 2? Of course not. They're not the same number. So this is an instance where we would solve a linear equation that actually has no solution. There are no values of x that will make this equation true. So we're going to go back up to our definitions. And our very first one is are no solution, and that means that there are no values of the variable for which the equation is true, which means my number of solution is none. There aren't any available, and my example is 4 does not equal, or 4 equaling 5. Well, 4 does not equal 5. Algebraically, it looks like that A does not equal to B. They do not equal each other, so that means there would be no solution. So now let's flip to problem number 2. All right, so here we're on problem number 2. You can see my copying didn't go so well. There we go. So same thing, I see that I have variables on both sides, so I'm going to either draw a line or use my highlighter to go ahead and separate. That's my imaginary wall. I'll use my Post-it note to focus on the left side. First, I look to see if there's any distributive property. There's not. I look to see if there's any combining of like terms. There is not. So I know that my left side is completely simplified. So I move my Post-it note over to the left side and cover that up so we can focus on the right side. I look to see if I have any distributing property. I don't. Look to see if any combining like terms. I also don't have that. So now I know that both my left and my right side are simplified. So my next step is to make sure that I move my variables over to one side of my equation. So I see that this is a -x, which I know is the same as a -1x. So in order to move it to the other side of the equation, I have to add 1x. So 2x plus 1x is 3x. Minus 4 is equal to -1. Well, now I'm back to asking myself what's happening to that variable of x. I see that I'm multiplying by 3 and I'm subtracting 4. So I need to get rid of my 4 first by adding 4 to both sides because of the reverse orders of operations. So my 4's cancel out. I have 3x is going to be equal to 3. Now I've multiplied by 3, so to undo multiplying by 3, I have to divide by 3. So x is going to be equal to 1. So what this means is that if I plug in this value of 1 up here, it's going to make that equation true. So let's try that out. So we have 2x minus 4 is equal to negative 1x minus 1. So according to this, if I plug in or I substitute my x equals 1 into my equation, I should have an equal sentence. So 2 times 1 minus 4, and then negative 1 times 1 minus 1. So all I did is wherever I had an x, I put in that value of 1. 2 times 1 is 2 minus 4. Negative 1 times 1 is negative 1 minus 2. 2 minus 4 gives me negative 2. Negative 1 minus 1 gives me negative 2. So I've now checked it. My answer is correct. This equation has exactly one solution. One answer will make the sentence true. So if we flip back to the front, you'll see my second definition. This is where you're going to have that variable, and x is going to be equal to something. An example, x being equal to 2. There is only one solution. So the equation is true for only one value of the variable. All right, so let's flip to problem number 3. All right, let's fix this a little bit from the copying. All right, so again, same process as we've done before. I see that I have that equal sign and I have a lot of things on both sides. So I'm going to go ahead and draw my line or my highlighted down the middle. I'm going to use my Post-it note to cover up the right, and I'm going to take a look at the left. I look to see if I have any distributive property, which I don't. I look to see if I have any combining of like terms, which I don't. So I know that my left side has been completely simplified. So then I focus on the right. So I look right away and I automatically see some distributive property. So I multiply 2 times my 1x and 2 times my negative 2. So I end up with 2x minus 4. So now I have no more combining of like terms, so I know that that side is now simplified. So because I had to simplify the right, I need to make sure that I bring down the left. So same thing that we've done before is we try to get my variables to one side of my equation. I see that I have this positive 2x, so I want to subtract 2x from both sides. Cancels out. Oh, those cancel out. So now I have negative 4 is equal to negative 4. Well, does negative 4 equal negative 4? Of course it does. So again, this type of solution is actually called infinitely many solutions. There are lots of values that we can plug into x that are going to make this equation true. So we can just pick a value. We're currently borrowing Mr. Boland's room, so Mr. Boland, welcome. What value do you want to plug in for x? You can pick any number you want.
23.
Seriously. All right, so Mr. Boland picked the number 23. So anywhere, we're going to try this out and see if it works. So Mr. Boland picked 23. So now we're going to go ahead and we're going to plug in 23 and see if it works. So 2 times 23 minus 4 equals 2, and then in parentheses, I have 23 minus 2. All right, so 2 times 23 is 46 minus 4. And then I always have to do order of operations. I have to make sure I do what's inside the parenthesis first. So 23 minus 2 is 21. Then if I go on to this next step, 46 minus 4 is 42. 2 times 21 is 42. So even though Mr. Boland had no idea I was going to ask him to pick a number, the number he picked of 23 still worked and made this equation true. So let's flip back to our definitions. And my third definition, as you can see in the algebraic form, it says that A is equal to A, which the example I happened to give you was negative 3 is equal to negative 3. So the type of solution is infinitely many. So what that means is that the equation is true for all values of the variable. So kind of another neat way to look at this, and this leads into later lessons later on, is that when we think about these are all linear equations. So I'm going to draw a coordinate plane. Here is my coordinate plane. So these are all linear equations. All of these form lines. So if I think about my first line here, which is this 2x minus 4, and again, we're just going to kind of draw some lines on here to kind of give you an idea of what a no solution is. 2x minus 4 is going to look something similar to this. Okay, there's that line. Here would be like my 2x minus 4. But then my 2 times the quantity of x plus 1 is going to look something similar to this. So what kind of lines do we notice these two lines are that are never ever intersecting? They're going on forever and ever and ever. They never crisscross.
If any staff member wants food, there's pizza in the workroom. If any staff members want food, there's pizza in the workroom.
However, by the time you are watching this video, there is no more pizza left. So if we look at these two lines right here, these two lines are actually parallel lines. They're never ever going to crisscross, which is why there is no solution, because these two lines will never intersect. So then if we flip over here to my one solution, so same thing, I'm going to go ahead and I'm going to draw a coordinate plane. And we'll focus on these two lines. Again, this is my x-axis and my y-axis. So if I look at this very first one, I've got a line that's maybe going like this. Here's my first one, that 2x minus 4. Then my next one is that negative 1x minus 1. So that's going to look like something like this. Not quite totally accurate, but if you notice, these two lines intersect. They intersected at one point, which should be x equals 1, but it's not quite drawn to scale, but you get the idea. All right, so then if we look at infinitely many solutions, which is kind of nice, kind of neat to look at, and I draw, same thing, my coordinate graph, and I draw this, and I think about where those lines are going to go. That 2x minus 4 kind of going something like this. That's my first one. Well then, I'm not sure if anybody noticed that when I did that distributive property, if you see right here, you can see right there, that's the exact same thing, 2x minus 4. So what that means is that these are the exact same line. So that's why I have a solution here. I have a solution here. I have a solution here, a solution here, a solution here, a solution here, so on and so forth, which is why then Mr. Boland could pick any number he wanted, whether it would be negative or positive, and that would make that equation true. So now at this point, what I want you to do is make sure that you go up and check with the sub and show them that you have all of the notes completed and everything is filled out, and the sub will go ahead and give you your homework assignment for today.